Hi, my name is Yves. I come from Belgium, so that says nothing, obviously. Uh, um, I'm going to talk about projections today. Reflect a bit, show some practical things so that you get a feel for what they are. Anybody write projections? That's fairly a lot of. Anybody not know what projections are? Okay. So there's a bit of both in the talk, basically, for everybody, I would say. Not going to talk too much about me, but I mainly work as a contractor and a consultant for other companies. And I've written some open source software that is quite tailored to this topic. So let's position projections since circa 2009. So I think it was around 2009 we got CQRS, publicly at least, and CQRS gave us something. So CQRS is mainly saying we split the reading from the writing. Where there used to be one service, there are now two services. And that brought opportunities. We started to entertain the idea that the model that we use for writing was maybe not necessarily the model that we use for reading, right? And we could make different decisions for each model. Now, this is mostly, I would say, a logical separation, not a physical one. There's a lot of people that automatically assume that it's physical. It's like there's two data stores or something like that. That's not what the patterns is about. You could be using something like Elasticsearch, for example, and automatically have CQRS applied because it's applied under the hood, because it does asynchronous indexing. And then a little while after that, or around the same time, I would say, we got event sourcing as well. Now, event sourcing is not necessarily applied together with CQRS, right? Did somebody already today give a definition of what event sourcing was? Yes, okay. What was it? Nobody? Nobody dares? Okay. Well, it's a fairly simple pattern, right? I think when you were looking at a few years back, when systems were traditionally built, what you get was you had no state, you did something to the system, and all of a sudden you had some data, some state. And then you did something else to that state, and then you got a new state, and another one, and another one. And when we modeled this in relational databases, we tended to mutate rows, right? We lost basically what that previous state was. What event sourcing does, it does the same thing, but it takes a very different focal point. It doesn't care about no state and their state. It cares about how we got there. So it's looking at those transitions, basically. And you get this type of architecture, which is kind of circular, right? You do a query, a user makes a decision to do something to the system, sends up a command, and maybe that's accepted, maybe that's not accepted. And then out comes an event, basically, that is used to, again, affect the future state. Because you'll probably have a next question to the system, right? And then when you apply CQRS and event sourcing together with domain-driven design, you start to understand that you're not applying that at a system level. No, you're applying it at a context or a bounded context level. Why? Well, not all problems need solving with CQRS and event sourcing to begin with. Some problems are data related. CQRS and event sourcing is good for things that are collaborative, that are behavioral, and how we got here is as important as where we are. That's one of the things it brings. But again, you do this in different contexts, right? Now, projections basically sit. Oh, that's not showing up. Is it? Nope. Anyway, it's sitting over there where the red pill is. And the reason why projections are sitting over there is because where the green pill is. So you design projections for a purpose. Sometimes I meet teams and they go off and they start doing projections and asking them, why are you doing projections? You don't know what your requirements are for your consumers. So why would you start off doing projections? Now, there are cases where you want to go off and actually start with projections is when you have no clue what data you'll probably need and what shape you'll need it. And you'll probably design it in some third normal form. Now, that's all fine and dandy. So what happens there is that on the right model side, the side where your entities live, basically the things that are actually producing the events, right? Those events get produced and get stored in an event store. Oh, yet another concept. Did somebody already explain what an event store is today? Right? It's not that, I mean, the people of Eventstore are probably gonna not like my definition here because it's so simplified. But I mean, at the core of it, it's a collection of streams. And you can think of it this way, right? You can have stream X with a number of heterogeneous events. I mean, you can store the same event within a stream, or you can store multiple different types in a stream. And that's how my mental picture is of what an event store gives me. Now, each stream basically is a sequence of events partitioned by some key. And this is where it gets interesting, because that's very much something that happens on the right model side, where you decide what it's going to be. You make that decision based on the fact whether or not you have some invariance to protect. Dare I say the word aggregate here, right? So the aggregate is probably going to have a corresponding stream because it has something to protect there. And so the name or the key might be the identity of your aggregate along with what type of name it is. And so you get something like this, right? And could be different, for different type of entities, you'll have different types of streams with different types of events going in that. Now each event, and I think this is one of those things that you need to learn about an event store, appears at a certain version within an event stream. I'm using the word version here because it's in most predominant event stores what's it's called. And a version is basically a monotonically increasing number within your stream. So you start at 0, or if you're one-based, you start at 1, and go 1, 2, 3, 4, 5. So each event that you append basically to that stream gets a version number. Why is this useful? The reason it's useful is because in the relational database world, you had this optimistic concurrency column basically, which you used to control whether or not an update could go through, whether or not somebody else did something. Well, that's basically what this version column is also giving you. And again, different streams. Each stream has their own, basically, numbering, sequence numbering. Now, it's not just that version number. You also get a position. And how is a position different from a version? Well, it's almost like you got these streams, basically, X and Y, and you're projecting them down onto a plane, and then you get, as you project them down, basically, you get a new number. And that new number is across all streams. it's not predictable. It's not stable in the sense that you can't predict in advance what position you're going to get. The version is predictable, but the position is not predictable. However, as soon as it's written, basically, as soon as the event is appended, you do get that position. And if you read it again, it'll be that same position again. But transactions that are in flight, you don't know the ordering. You cannot assume the ordering. Why is position important? Well, when you're writing projections, you want to have this type of cursor, basically, across all events for some projections. Some projections have a stream affinity, meaning they're almost one-to-one to a stream. So let's look at an example. So this is probably the canonical example that everybody uses, is online shopping. Different color coding for the different types of event that we have. Somebody started shopping, an item was added to a cart, was removed from a cart, and the cart was checked out, or somebody basically abandoned the cart. And this, to me, is basically how our system works live. Now, I would say that Jane and John are pretty fast shoppers, but that's kind of the behavior that you get. So each time, as they're doing things, they send up a command to add an item, to remove an item. That gets translated into an item was removed, an item was added, basically, or I checked out my cart. And then as all that is happening, you get all these numbers being assigned to those things, those events. Fine. Finally, we have a filled event store, right? I still haven't talked about projections yet. That's deliberate. There's another concept that you need to get that cursor, basically, which is basically a subscription. And it's a promise or an agreement you get to be notified whenever new events arrive or have been appended, basically, to a stream. And typically, you set it up as a consumer. Typically, you get that from the Eventstores client API, or if you're building your own, basically, that's something that you'll need to take care of. It is one of many ways to feed projections, but it's, I would say, the most predominant way in which you would do it. You can start off as of a known position in the all stream or as of a version in the stream. It depends on what you're subscribed to at that point. So again, here, the all stream subscription. So you get this type of cursor that runs over it, right? Now, this is fine when it's live, like when these events would be written in that order. But when the events have already been written, basically, that cursor would be like that. Why? Because as fast as you can consume them is as fast as you'll get them. So that's the difference, right? Now, you can also observe them, basically, as of a known position. Why would that be good? Why would we start observing as of a certain position the events that have been written? Well, there's many reasons, but the predominant reason is obviously, what if you crash? You want to resume as of the point you crashed. What if you stop? You want to resume as of that point. So that's the facility that you get. That's why you're in control of the cursor. When you use something like a queuing system, you are not most often not in control of the cursor. Maybe you're in control of how fast you consume, but you're not able to reset the cursor. That's not something that you get. So finally, we get a filled event store, and the messages are starting to come close to our projections. So if we put that all together, basically, we get an architecture that resembles something like this. Like a user basically wants to make a decision. He needs some data. That data visually enters his head. He makes that decision. Out comes a command. He sends up the command. And eventually, that gets translated into an event that gets appended to a stream in the event store, which is then observed by a projection, which turns it again in data. Again, why it's called a circular architecture, right? And this happens over and over. I can watch this diagram all day, to be honest. Now, what is a projection? Well, a projection is the act of transforming a stream of events. Or it's the act of deriving state from a stream of events. Well, is that kind of the same thing? Sure. Or it's the code that enables that transformation. Or talk to another person, and it's the data structure being filled using events. You know, it's this type of overloaded term, basically, that's, and it gets so many meanings. And they're all kind of right and all kind of wrong, basically, in the sense that, to me, the projection is that transformation function from an event to some side effect, basically. But there's a data structure involved, for sure. But a fundamental question, obviously, that we have to ask ourselves, what's the reason why we would project at all? Why do that? Well, continuously asking questions, basically, by replaying events, well, that's probably going to be suboptimal, right? I mean, if you have a 2-year worth of events, millions of events, basically, and you want to ask a question and you have to start from the beginning and interpret each event. To answer that question, that might be suboptimal. Now, you also might want to do things in the sense of, for example, you might want to search for somebody's first name or last name. An event store was not built for that. We have other solutions for that, right? So we want to move or interpret the event streams and move that data into some other shape or form so that it's easier to query. And obviously, it's also a way to cater for that decoupling from what happens on the write model. Stays nice and clean. It's concerned with making sure that your business rules are enforced. Whereas on the projection side, you're maybe looking at how can I best feed the responses of my API? How can I best show this data on a screen, right? So derived state can be stored in, well, pretty much anything you want. I mean, you can basically pull data out of EventStore and put it in Apache Kafka, which is another stream database, and go off and interpret it there. But Apache Kafka is not an event store. Let's get that right. You can, I mean, there's all kinds of reasons why you'd move it in one of these things, because you're trying to solve a particular problem that these storage engines are good at. Now, there's a lot of decision criteria that go into that. And there's a lot of ilities that have to do with that, right? You're looking at non-functional requirements as well as functional requirements, I would say. But for me, what I've observed is that the driver and connectivity support in your ecosystem, because, I mean, that's also one of the things I would say, that when people have a stack, they tend to do everything in that stack. Whereas for projections, I would gladly move off that stack, basically, if it has a better driver or connectivity support. Sometimes people, when they write projections and they target a certain store, they kind of neglect the transaction model of that store, and then can get bitten when things go hairy, right? When a transaction fails, when the network is not there, when did that write actually happen to that other store? How do I know? How do I recover from that? And you're obviously looking mainly at the querying capabilities that a store has, right? If you want to search, well, there's only so many options for search. So At the end of the day, it's choosing the right job for the tool, right? But those are some of the things that I would look at if I were to pick a certain store. And that's one of the beauties, basically, of this approach, is that you can make a deliberate different choice. Now, obviously, you'll need to look at the maturity of your organization. Are we able to run all these stores? And how many are we able to get away with, right? So when people talk about projections and read models, I kind of get the impression that people use the word the read model. There is no such thing as the read model. There are n read models stored in m stores, basically, right? So there are many projections that you can build for different purposes, for different paces of change, for different consumers. So if you're building something for an API and that API has a different versioning story than your UI, your best bet is probably to decouple the projections. Meaning that, yeah, you build them twice, but for different purposes. They change for different reasons. Now, you might make a conscious decision about that because of the fact that, oh, look, 95% is the same. That's your decision to make, but I mean, it's good to reflect on these things and think about it, right? And then you fill it in with, obviously, specific technology that you want to use for that. There's an aspect of analysis and design to projections, yes. I don't see it happen very often. It's almost like projections is this last thing in our architecture that we're doing. It's gotten a bit of the name of that. It's what juniors do. I tend not to agree with that. It's not complex. I'll tell you that. But there is some analysis necessary. What kind of analysis and design? What does it mean to analyze, basically, for projections? Well, basically, you must come up with what's the optimal data structure for a given projection. Which events are we going to subscribe to and use to actually fill that data structure? And where are we going to store it, basically? Those are the three predominant things that you'll have to decide. Now, my observations have been basically that projections and data structures are at the mercy of certain influences, if you will. Most predominantly, obviously, the consumer, because, yeah, what am I trying to get out of as data, right? So that might dictate how you store it and how you shape it. But then there's the transactional model that's, I mean, think about a nested or a hierarchic structure in a relational database. You might use multiple tables, whereas in a document database, you'll probably use a document, right? And then there's the events that also kind of put pressure on, wait, we got this event, but it's missing this data. How? So these are also feedback loops, right? So when you're designing your projections, ultimately, somewhere over here on the right model side, we made the decision that these would be our messages that we would use in our system. And we made conscious decisions about what goes in that message and what we named it. But ultimately, it's an abstraction to solve a certain problem. Meaning that nobody is right. Some events are useful, more useful than other events. And the way in which you design them is more useful than other events. So there's nothing wrong with revisiting your events, basically. Now, obviously, when you're past the design phase for your events, things are different, right? It's not that easy to change. Why? Because events don't change. They happen. It's their shape and their form in which they are. But when it may come off as the fact that projections are something that you do at the end of the software development. No, obviously not, right? You make a tiny piece of software on the right model side, and then you might think of how do we want to surface that in a UI or in an API, for example. So you get a very iterative approach to it. And that's the moment in which you need to react and look at whether or not your events are missing data or context. And some people are very pure about that fact. They're saying, well, no, my events need to be thin. And then they run into trouble somewhere else. So sometimes it pays off to be a little bit more pragmatic, I would say. So what these data structures capture is data used to identify rows, values, documents, whatever you will. Obviously the data that you want to return to your consumers, but also the data that you want to filter on. That also needs to be within your data structures. Like security, for example. Am I able to view this piece of information? Where is that coming from? How do I filter that? How do I know that? Is that sitting in some other system? Maybe you're doing paged results and then applying that filter on top is just plain weird because it messes with your paging. So you might invert that and basically say, well, I'm going to project who's able to view that. I'm going to project, as part of my projection, basically, which roles are able to view that piece of information. And then when a user comes along and has a certain role, you just query where that data equals that role or is in that role. Obviously, some data is stored so that you can apply future events to that data structure. Like a name and an ID, basically. You're only interested in the name, but when that name changes, yeah, you probably want to find it by ID and not by name. So writing projections. So you design them, obviously, you also write them, right? So you write a piece of code for those projections. I would say that most often you write them as cohesive units. Like, what I mean by that? Well, the events that affect a certain data structure basically are put together close to one another in code. And you should be focusing on what they need to do, not on how they do it. I see a lot of people writing projections with a lot of boilerplate in there. You need to get that out there because, I mean, depending on how long your system is going to be around, I've written systems where we gotten up to 200 projections basically. If I not written them in a certain style, it would be very painful to change certain things. And obviously, yeah, be true to your platform. If you're using functional programming, use functional programming, right? There's many ways in which you can write projections. But ultimately, it's a function that takes state. An event produces new state. Well, sure, if that state is stored in memory. Could also be an event that you interpret and you produce a bunch of statements. You know a language that does that? It's called SQL. So you observe the event and you know that this is the first thing that happened. So I want a new row over here. Insert into table data. Right? Same with update, same with delete. Has a nice property to it. Because you can basically generate the SQL that goes along with it. Doesn't mean that you need to execute it at the same moment in time. So you can introduce things like batching, which is probably overkill for when you're live, subscribed to what's happening. But when you're replaying, that makes a world of difference. You also have the connected model where you basically have you get a connection to something, to a database or some client API to something, and then you somehow need to talk to that client API and interpret the event and create a data structure or update a data structure in there. And then there's all kinds of varieties depending on your ecosystem and where you're at. I've seen people that use service buses basically and then use message handlers that are available in their service buses. If you're in the actor world, well, a projection could be an actor. Actually makes a lot of sense. Yeah. Well, Let's maybe look at some code here. Is it readable if I stop scrolling, obviously? So you get a bunch of events here. Get started shopping added. I mean the ones that we've seen already, right? Now, I'm also defining I'm using F# here, so I'm defining a union type that represents all these events as a shopping cart event. So it's either going to be one of these, right? So it's going to be get started shopping or added item to cart, etc. And there's some ugly code there to kind of move it from into JSON. But one of the nice things is that you can start telling a story with your events. You can write them in code, basically. That's where the usage comes in here. And can start describing a little story about what happened. It's an interesting property if you're able to do that in your language. So here I have a projection that I've written. And the projection, the data structure is the number of active shopping carts at this moment in time, or at a moment in time in my system. So the things I'm interested in is, well, when somebody started shopping, when they abandoned their cart, or when they checked out. So when they started shopping, yay, another active cart. When they abandoned or checked out, well, that's when they stopped, right? So projection is nothing more than a function taking some state, which is the active shopping carts that I've shown you up there, and the event being a active shopping carts event. So when the guest started shopping, I do +1. Here do I -1, -1. Obviously, this is a very simplistic example, but it drives home the idea that this is how complex it should be. If you have any more boilerplate in your projections than this, I mean on the functional side, right? Not on the infrastructure side. Now, I have another one over here, and it's a little bit more convoluted, I think. So this one was across streams. So if you have many people shopping at the same time, I'm not really interested in each one of the streams. I'm interested in across all the streams, right? Because that's the counter that I'm keeping. Obviously, I'd use a time series database to get that, but it drives home the point, right? Here in this projection, I'm maintaining a cart document, probably because I want to show what's in your cart. So I need more events for that. I need to know which items you put in there and which you removed. So here I'm matching when you started shopping, basically. And I'm going to try to scroll a little bit over here. When you started shopping, I'm going to add a new document to map. So it's an in-memory data structure where the key is the cart, and then the document that I'm maintaining is, well, actually the view that I want to have on the data. So when I start shopping, obviously I don't have any items in my cart. And then when I added an item to the cart, obviously I want to add that. When I remove it, I want to remove it so that I always get a consistent view of that cart, right? Now this is a different projection. Why? Because actually what it's interested in is one stream at a time. So an interesting question is when people design projections like this, basically, what they'll typically do is they'll hook this up to the all stream as well. Now, there's a bug in that code. And what happens to Jane's shopping experience when John's shopping experience makes the projection blow up? Do you want to block each and every one of all those other people shopping basically at that point. So you need to find a way to make sure that all the other people are able to continue. Now, one of the ways to do that would be to put on the document basically, well, this card actually failed. If there's any future event for this one, just skip it and continue doing with the rest. And we'll fix that other one. Well, not so much manually, we'll fix the code and we'll replay that specific card, and then we'll catch up live basically to make sure that all the other cards are still working. Now, what most people tend to do is they'll tend to interpret the raw event, right? So here it is, the raw, well, not so much raw in the sense that it's the typed thing within your language, right? So when I say guests started shopping, that's what you get into your projection. If you want to be able to deal with failure, if you want to be able to deal with, did I see this message before, yes or no? Did I see this position before, yes or no? I'd encourage people to use an envelope basically so that you can make those types of decisions within your projections. So write a little envelope basically that gives you the position and maybe the message ID of the event. And you get, in your projection, you get the envelope. I'm not doing anything with the envelope here, but I mean, I have it at my disposal, so I'm able to. So this is another one, basically, this is the SQL one, where each time I observe an event, what I do is, well, I emit a SQL statement to be executed later on. So these are just lists of things that need to be executed, right? Nothing complicated about that code. In the connected model, I'll probably give you a SQL connection, and then there I'll actually execute the commands, the SQL statements that have been produced. That's what you get with a connected model, basically. I just wanted to show you the different styles of doing these things, right? Don't worry, the code will be available later on so that you can basically look at it. Now, so there are different ways in which you can write them. It's going to be bespoke for your situation, for your consumer, for your requirements, for your storage engine, basically. But there's smells in there. There's smells in there. Complexity. If a lot of ifs in there, why do we have a lot of ifs in there? It might be that it's just the way it is, but it might also be that we didn't deduplicate the events. There's multiple intents basically sitting somewhere else. So it's again a sort of a feedback loop. And that might basically make your write model a little bit better. Sometimes you'll see the need to have external state. Or I want to depend on that other projection that I've written there because the customer name is in there and I want to enrich it over here. And then you start doing replays and boom, the whole thing blows up. Why? Because, well, it's not that customer name that I want to put over here. It's the historical name that I want to put over here. But that thing is already here in history, whereas I'm trying to come up, basically. There's repeated logic in your projections. That's also a smell. I had this when I was working on a patient administration system where I needed to know how much time was still available on a certain day. And what I was seeing, that computation existed in my write model side because I needed to guard the fact that you would not overbook basically on this side. And this was a domain rule, if you will, an invariant that needed to be upheld. And then on the other hand, when you're searching, I also needed to make sure that if you were searching for a certain type of appointment and that appointment was like 90 minutes, but there's only 60 minutes left, well, there's no reason why I would give you that slot, basically, because there's 60 minutes left. There's not 90 minutes left. And that same logic will creep into different places. So again, it's a feedback loop. I'm not saying that all these things are bad, but it's something that you need to pay attention to. Some people have very big data structures for their projections. I'd say look again at how you're composing information. So testing. Do projections need to be tested? Some people say yes, other people say no. Some people say, well, not projections themselves, but the consumers need to be tested so that the projections are tested indirectly. I think it's a matter of how complex that gets. If I need to spin up an HTTP server to send an HTTP request, how am I going to get that data in there so that it's... Then there's security to be added. It's too far away from the system under test for my taste. But, I mean, I'm not dogmatic about these things. So I do think there's a place for testing, right? The act of verifying that it behaves as expected. So we write these things mainly as specifications, specific type of, preferably executed as an integration test. Why? Well, building yet another abstraction on top of your storage engine that you're going to project into may not be the best of ideas. I say may. Sometimes when you want to do this, some people have this idea when what they're projecting to should be able, they provide an abstraction that provides you with a finite set of methods that you can invoke, which largely mimic insert, update, and delete. And then they want to be able to do that partially in memory and then flush it to the database, or what they want to do is so they want to have some kind of batching going on basically as they're doing that. That's probably the only use case where I wouldn't use the integration test. You can integrate that with any unit testing framework that you're already used to. There's nothing special about the code, to be honest. So the anatomy of a scenario for a projection is basically, given this has happened, I'm expecting this to be in the store. That's it. Nothing less, nothing more. It's important. It's the same type of test that you write on the right model side for your event-sourced entities or aggregates. Given these events have happened, when I do this command, I'm expecting these events. The same kind of feel to it. Right? Well, you can also make a builder out of that. This is me trying to abstract basically that. I tried that. I failed miserably. Why? Because each storage engine has a different type of verification phase, and this was the best abstraction I could come up with at that point. So given either nothing happened or given these things have happened, then please verify. Anyway. So I have some infrastructure over here. And then a test might look something like this, where it's here at the bottom, right? So given a guest started shopping, I'm expecting within the map be there a new shopping cart document. And now please go and assert that projection basically behaves in that way. All the rest of the boilerplate are how you integrate. If you want to do this with an integrated event store, if you want to do this with an integrated storage engine. I mean, these days, it's a no-brainer to use Docker. Basically, you spin up a Docker instance at the beginning of your test suite, and then you go off and run your tests. Initially sequentially, and then you find other tricks, basically, to make them run in parallel. But none of that should enter basically your specification that you're writing for your projections. Now, you'll get feedback from tests as well. In the sense that verifying can be painful. Why some stores are not easy to bootstrap, although, as I said, I mean, these days it's easier to do. But their consistency model is at odds with how, I mean, some stores are really hard to just ask them, please give all the documents that are in you. And then some people come up with, well, we'll do a query. And that query then tries to hit an index which is not yet up to date, which kind of makes your test fail. And then people know, oh, I know what to do. Let's add a delay in there and wait a little bit. I mean, that can work. And I'm not saying I have a solution for that because, yeah, it's just the storage engine that you picked. But that's some of the things I see in the wild happening, basically. And then there's also test specification authoring pain, where, I mean, to be able to change one Boolean, basically, I'll have to set up a whole lot of things. Well, why is that? Again, not saying it's bad. I'm just saying, well, why is that? Think about it. And again, here also is that people sometimes end up with data structures that are way too big. And so these projections are becoming magnets of all the events within your, well, a large subset of events within your system. Oh, some questions. I'm ahead of you. So the question you had, or I may have answered. Can one projection depend on another projection? Well, I'd say no. You get into trouble when you're doing replays, because now you have to coordinate which projection do I have to replay first. You get in all kinds of topological sorting issues. It's doable, but it's not fun. So use this word replay. What does it mean? Well, it's resetting your cursor and your state basically to a certain known point, and then continue playing the stream right until you're caught up with all that's in the event store at that point. You have a need for a projection to do something at a certain point in time. This is a fairly common question I get. How do I go about that? Well, it's very easy. Time is a message too. So if you don't have need for for something that needs to happen at a higher frequency, if you have a need for something that needs to happen at a high frequency, you're probably in memory and not on disk. But if it's this type of things where you say, well, at the switch of a day, basically, I want something to be cleaned up within my projection. Well, you can write a stream that is basically a clock and says day has passed. And then when the other day has passed, it writes again an event, day has passed. And now your projections are able to observe that, just as they would observe any other message, basically. You're probably not interested in all the pastings of this stream, because, yeah, you're just going to delete that, but it can be a useful mechanic to get your projections to do something. So sometimes you have a need to enrich your data structure and your projection with data coming from past events, things that happen before you actually handle the event you're handling now. So the way you can work around that is by using lookup caches, like in you could do that in memory, or you could do that on disk, basically, or in a separate table on the side, basically, where there's a name that you need to enrich with. Well, you're able to do it that way. But you do have to ask the question, obviously, is the projection the right place to do the composition? Sometimes you want the data to be as fresh as possible, and then the UI or a controller sitting behind that is serving a request may be the better place to do the composition. But then you have temporal coupling, because now the system that is providing you that information may be down. There's other places where you can do enrichment. You could do it in the user interface right before the command is being sent. But now, do you trust what the user interface is sending you? There's ways around that as well. And then there's, in the command handler itself, you can basically say, well, let's enrich the command with the data that's needed. And it'll be copied to the event. Some people frown upon that. But basically what you're saying with an event is, at this moment in time, to the best of my knowledge, this was the data that was associated with X or Y. Like this was your name as a customer, for example. Even if you change your name later because there was a typo in it. Now sometimes people ask, well, I need data coming from somewhere else. You could obviously inject the service into your projection. I mean, it's just another dependency. But yeah, here be dragons, right? It's the same type of problem that you would have somewhere else. So some people have a lot of data in their projections. Well, yeah, they get a lot of data in their projections because they have a lot of events. And now I vividly remember somebody emailed me and said, well, our projections are taking 8 hours to just go from 0 to a new state. And then there's a simple question to ask. Of all those past events, how many affect the future? Meaning that, are they still useful? Are you still basing decisions based on old facts? So there's a lot of data that you actually can move off of your event store. It's domain specific, right? Fiscal years, end of a period. You can even break it, like, for example, casino wallets, for example. You have a player and he has a lot of history of money going in and out of his wallet. You can basically say, well, here's a new wallet, which is a new stream, and then have the old wallet point to the new stream. And that old stream, basically, that you no longer need after a certain amount of time, you can take it out, put it somewhere else, right? And that keeps the volume of data, basically, that you have down. That's just one example. But I think the more general advice I give, partition more along the axis of time and space. Meaning that if you have a lot of organizational units, why are they all in the same database? Maybe they are geographically distributed. Maybe that's not even a good idea to begin with. But again, it's domain specific to get to these answers. One of the possible other solutions is to kind of take it offline. Meaning that you do the replay offline, and then when you caught up these 8 hours, you pretend as if it's the flip of a switch, basically, and then it looks as if you did it in a second, but obviously you did it offline. How are we on time here? Good? Yeah. Okay, last topic. Hosting. So hosting is the technology and the services that make a projection work at runtime. This is some people are very advanced in this topic. For me, it's been a journey of exploring, basically, what could be done. And I've seen various things. There's an awful lot of trade-offs that go with this. It's often fairly generic, meaning that you're not going to be rebuilding this for over and over again. Although most people, most projects I see tend to build it themselves. But what I mean is that once you've done it for one project and it kind of works, then you're able to take it to the next, if you will. Now, the storage engines might dictate a bit what you are able to do with regards to failure management, but all in all, it's fairly generic. So this is one deployment I had at a certain point in time, where the servers up here, my clicker is not working, so I'm going to explain that way. So the servers up here basically are serving both the reads and the writes, so meaning your queries and your commands, right? And they're writing to the event store, and then the projection, which is the P over there, is the thing that observes, obviously, what's happening in the all stream, and then decides to project that data into yet another store. And that is then queried, which is what the R's are here. So when a query comes in, it basically goes to that store, gets the data out, and routes it back. So you could have the write nodes and the read nodes separated for all I care. You could have them do both, basically. Think of an API where you join basically both reading and writing. Great for failure management, I would say. If one node dies, then well, not everything is down. But what happens, I mean, there's a problem here, right? Can you see the problem? That's one node. Projections are isolated. They're almost like single-threaded, right? There's no use doing parallel writes. So you want to make that highly available. So you have multiple nodes, basically, that do that. If you set it up in that way. Another way might be if you're on an actor framework, for example, then then that might take care of that for you. Another deployment that I've seen, or how they're hosted, is basically where the writes and the reads are separated. Essentially, it's the same thing, but it's just that you get different types of nodes, and then you can put in a different type of barrier. For example, the writes happen somewhere else, and then a lot of people observe or want to query that data, which is not necessarily the same people as the ones that write the data. And then there's another variation of this where basically the projections live on each one of these nodes. So it's again the same as the previous one. The reads and the writes are being served by this one, but the projections also live on here. Now you get into some interesting behavior there, because what happens basically when node 2 is faster than node 3 in projecting? You're querying that data, you might get data out of order. There's e-tagging and things like that to make sure that you don't read old data, but it's challenging. So the main hosting within a process basically looks a bit like this. You have an event store, you have subscription, which is bootstrapped by your main, and then your projection observes that and stores it into whatever store there is. You can also have the store in memory, obviously. There's a thing to watch out for, though. What if your event store is not available? What if the store on the other side is not available? Network outage, flaky connection, I don't know. You're coming online too soon. It's also one of these things where your projection node basically is coming online too soon, and yeah, the event store is not yet online, or somebody took it offline and wants to put it back online. So you want to build in, with each of these question marks, you want to build in some resilience, which is why I added another sphere around that, basically, so that you're able to recover from those situations. Your projection might be buggy. How are you going to deal with that? I'm not giving you answers, but I'm giving you questions, basically, to answer for yourself. And then this is another model where, a fairly common model, where people actually don't have one projection with one subscription and one process, but they have multiple projections sitting behind one subscription. You can do that in memory as well as in, but you get a lot more question marks here. What if the top projection is very slow? It's basically hijacking your subscription there. Because if it's slow, that means all the other ones are going to be slow as well. Why? Because it's not able to move on to the next message, basically, if that thing is slow. So, projections. Do you have any further questions for me about projections? Yes?
Sir, please.
Just Okay.
Hello. Okay. Thank you for the talk, Yves.
Yeah.
What if you can't have the all stream because of the scale that you are dealing with?
Well, that's a very specific problem, I guess, right? I think it's going to be easy to write the projections that are stream bound, like, but anything else, yeah, is going to be, I wouldn't say problematic, but you will need to find a way to kind of, tunnel all those events basically into something that looks like an all stream. It depends on the technology, right? I mean,
Sure.
most like Cosmos DB and DynamoDB both have this way of observing all the changes that happened. If there's no way to have that, I don't really have an answer for you there. What to do there? So as I said, it's going to be easy for the simple projections that are stream bound, but it's not going to be easy for the other ones.
Right. Thank you.